70-741 Lesson 11 Implementing DFS and Branch Office Solutions. What is DFS? DFS is Distributed File System. In this lesson, you'll be learning about Distributed File System and Branch Office Solutions. You'll look at installing and configuring DFS namespaces, configuring DFS replication targets, replication scheduling, remote differential compression settings, staging, so on and so forth. You'll also look at and learn about installing and configuring branch cache and how it's used, implementing branch cache for web, file, and application servers. Understand that over the last few years, Microsoft's devoted a great deal of attention to branch office computing and the complications that distance and isolation present to you, the IT administrator. Branch offices need to be connected to the corporate headquarters. Data connections cost money. So let's take a look at a chart, and if we look at this chart, we can see a typical corporation. Now, they have a headquarters branch that's large. They may have another branch office that is also fairly large, and then they've got this other office that is very small. The small office doesn't even have a domain controller. There's only 10 users in it. It's got a very slow, it's got a VPN connection. The medium-sized office has 100 users. We might think of that as being a large office, but it's not. In terms of an enterprise, 100 users would be considered a medium size. Now they illustrate this as having a T1 connection. Remember your T1 from Network Plus? As a side note, understand that a T1 is a copper wire connection. All your data providers, AT&T, whoever it is, has either phased out or is in the process of phasing out all T1s. Everyone wants you to go to fiber. It's faster and they can charge you a lot more money. But in that medium-sized office configuration, they show a single domain controller with a DNS server and a global catalog server. Remember that a site needs to have a global catalog. If you've got a domain controller in a site, you should have at least one global catalog server. And then in the large headquarters supporting 1,000 users, they're connected to a T1, which nowadays is probably a fiber connection, and it's not going to be 44 megabytes per second up and down anymore. It's probably going to be 50, 75, 100 megabytes per second, depending on the requirements of the corporation. But a minimum of 2 domain controllers, 2 DNS servers, and at least 1 global catalog server. And you'll see that they do list as having a separate site object for the large and medium. So how do you share information? Shares are going to be on different servers. How can you make it transparent? Well, let's look at this from a little different perspective first. Let's look at DFS that's already in operation. Here is a file server located in West Palm Beach. This is your DFS management console. You create namespaces. And what is a namespace? A DFS namespace enables you to group shared folders into a single logical structure. In other words, a DFS namespace is a shared folder of shared folders, which can be on multiple servers. And if we select this totaltruck.totaltruckparts.net, that's their domain name, apps is the folder, we can see these other folders that are shared within it. And it is shared across this server and this server. Currently, this server is not sharing it. It could be in the case of disaster recovery or whatever other purpose they decide to enable it. It's just disabled at the time. It's part of the structure. It's simply not enabled at the time. But coming back to your namespace, these are the folders that they're talking about as a group of shared folders in a single logical structure. And if we come over to Explorer, we can see here under their domain name, here's apps. That's that structure. And if I double click on that, there are those folders. So they're folders not being shared on a computer, not being shared on a server, but being shared at the domain level. And it's highly resilient because these folders are shared across servers. For example, if I right click on this programs folder and go to properties and look at DFS, I can see that it's actually being shared across 4 different servers. So this is highly resilient. If the West Palm Beach site itself goes down where 3 of those servers reside, it'll still become available from a server that's in Fort Lauderdale. So not only is it resilient across server structure, but you can make it resilient across your site structure. It's a very useful utility. So if we look at it, I'm going to close this view. And over here is another view of file server. Well, you can also share this through group policy. Here is shared drive T. Well, shared drive T is created through a group policy. If I double click on that, same view, except it's presented to each user as a drive that's being shared to their computer. How cool is that? They don't even have to navigate. All they have to do is open up File Explorer and it's already there for them. It's a very powerful utility. Now, those are the folders that hold the information. So you can see, for example, if we select programs, it's enabled on all these servers. Well, how does the information stay equal? In other words, if I make a change to a file or add a file or modify a file on this folder on this server, how does it stay the same to make sure that a user in West Palm Beach accessing it gets the same file? It's done through replication. And we can see here where that replication is what takes that information that's on one server and makes sure that it's uniform across all. And you can see here, to manage DFS replication, navigate to the replication group. Well, here are your replication groups. And if I select programs, the same, here's a very similar view, except now we can see replicated folder, what's being published. Here's the namespace that it's being published to, the connections, how it's connected in the structure, all the different information of how this is being replicated to make sure that change is uniform. This is how DFS works. So maybe that gives you a little bit different view of how DFS works prior to going in and doing a step-by-step and not really having insight into what you're doing. So you can also have maintenance items that you can do. For example, verify topography. If I'm going to select verify topography, it says, hey, it's fully connected, data can replicate through the topology. So if you're having problems, you make a change to a file in one folder, but it doesn't show up in the other, here's some troubleshooting methodology that you can use. You can create diagnostic reports and use that to verify what's going on in your DFS network. So that is DFS management. So let's take a look into the actual context of your learning. I'm going to go ahead and sign out and get off of that server. As you can see, that was a Windows Server 2012 R2. It's been around since then. We talked about the DFS namespace, but what about DFS replication? DFS replication enables you to replicate folders between multiple servers. So the namespace is a collection of shared folders. The replication allows you to replicate those folders across multiple servers. Okay, so when we go about to configuring our DFS namespace, there's 2 different ways to set it up: a domain-based namespace or a standalone DFS. A domain-based namespace, the configuration is stored in Active Directory. which means you don't have to rely on a single server to provide the namespace information to your clients. It's done through your domain controllers in your Active Directory. A standalone DFS, the configuration is stored on that server, and the server becomes part of the main path to the namespace. So it's not being shared through Active Directory. So when you, the user, attempt to access one of these namespaces, how does your system figure out which server and which folder to connect to? It's done through what's called a referral. It's an ordered list of servers or targets that a client computer receives from a domain controller. If it's a domain based, or if it's a standalone, it comes directly from the namespace server when the user accesses a namespace root or a DFS folder with targets. So after the computer receives a referral, it then reaches the first server on that list. If that server is not available, it then tries to access the second server. And if that server is not available, it goes to the next if there's a next, and so on and so forth. That's how those referrals work. Now understand that because it's a specialized shared folder of shared folders, you still have to secure these folders. You're going to need to secure them with share permissions and NTFS permissions. Make sure that you first configure the share and the NTF permissions on folders that host the namespace roots and folder targets before configuring DFS. If you have multiple namespace root servers, or if folder target servers will be utilized, you need to manually synchronize permissions between those servers to avoid access problems. Because what's going to happen is, if you set up your DFS and create all these folders, and then you start going in and setting your share permissions and your NTF permissions, what's the chance that you may do one differently on one than another? If that happens, you're going to have users who don't get access, and all of a sudden what was available one time doesn't become available another time because maybe they ordered list of servers changes. It can be very, very troublesome. So make sure you follow that. You configure the share and NTFS permissions on the folders that are going to host your namespace roots and folder targets before you configure to your DFS. This goes back to what I keep saying about everything we do. It's all about planning. You need to draw it out, you need to map it out, you need to think it out and look at exactly how you want this organized. That's the key to proper utilization and proper planning and proper deployment of your DFS. Now, in addition to those targets and namespaces, you want to configure your DFS replication. Replication enables you to replicate folders between multiple servers. We looked at that in the live example. It does it efficiently. It doesn't consume all your bandwidth. It uses compression. It uses scheduling. You can determine how much bandwidth will be used, when it'll be used. So it can be very efficient in the way that you enable your replication. The concept of a replication group is a collection of servers known as members. Each one of those holds the target of a DFS folder. So to do replication, you have to have at least two targets, right? If you have a single target, you can't replicate. You can't duplicate anything with just one. It's got to be a minimum of two. Now, understand, DFS replication is not a replacement for doing backups, because that replication will replicate whatever happens on one server. Think about that for a second. If I've got 10 files on server 1 in a folder, and those same 10 files are replicated to server 2 and its DFS folder, and I delete a file on server 1, what happens? That change is replicated out to server 2, and it gets deleted off of server 2. If a file gets corrupted on one server, that corrupted file gets replicated to the other server. You still need to do backups. This is not a replacement for backups. Now, when you configure your replication targets, understand that by default, replication groups are going to use a full mesh topology. Do you remember what full mesh means? It means that all members are connected to all other members. Let's go back to the example that I had where that replication group was shared between 4 servers. And we're going to call them server 1, server 2, server 3, and server 4. So that means that server 1 has a connection to server 2, it has a connection to server 3, it has a connection to server 4. Server 2 has a connection to server 1, which we already mentioned, but it also has a connection to server 3 and it has a connection to server 4. Now server 3, we already know that it's got a connection to server 1 and server 2, but it also has its own connection to server 4. So all servers get connected to all servers. That's full mesh. You could also designate it as a hub and spoke, where one server is used to replicate to the other members. Now, what is branch cache? So understand this came about because branch offices typically have a slower connectivity to the central office or headquarters. And you're not going to put the same infrastructure in place in a branch office that you do in your headquarters. It simply isn't cost effective. So when users access files over the slower WAN links, there's going to be a delay. It takes time. When you're using branch cache, you're essentially creating what we call a WAN accelerator. So we're creating a local storage where the information from that home office, that central office, that headquarters branch is going to get cached on a local computer. So if the document's cached, it's accessed from the local branch office rather than going across that slower WAN link. Makes it much more efficient. To do this, you have to install the branch cache feature and the branch cache for network files role service. Then you use group policies and enable it for a shared folder. Now, additionally, this lesson covers printers. So understand that print services are a basic service needed by most organizations. We need to have network printing. You can't, even if you've got an organization that's only 100 users and you've got 100 computers, are you going to go out and buy 100 printers and connect a printer to every single one of these computers? First off, they're connected by USB. How do you monitor the needs, the consumption of consumables? That's the ink, the toner, the fuser, the paper. How can you monitor that if it's a standalone printer connected to a computer? By using a network printing, you can have multiple computers print to a single printer. That also enables you to be able to monitor the status of that printer. When you print a document, the client computer submits the print job to a print server, which then delivers it to a printer that's connected to your network. So going back to the example I was just giving, when you install a printer, you've got basically 2 options: a local printer or a network printer. Your network printer is going to typically always be connected through a USB port. Windows is going to detect it. It's going to ask you for any drivers if it doesn't already have them. A network printer, the user doesn't need to worry about installing that. You can designate what is available to what print or what users. It's a printer that's connected to a dedicated server or a network device, such as a switch router. So anyone who can connect to the printer and has the permissions can print directly to the printer. So what are some of the options that are available when you're working with printers? Well, the General tab, you can configure its name, location, comments, print a test page. The Sharing tab does just that, allows you to share a printer. The Ports tab allows you to specify which port or physical connection it has. The Advanced tab, priorities, when the printer is available, how print jobs are spooled. Security tab allows you to specify the permissions for the printer. And the Device settings allows you to configure the trays, font substitution, and other hardware. As a home printer, our printers have one paper tray, but larger printers have multiple paper trays. They may have 2, 3, 4 paper trays, and you might have different paper in different trays. Or you have 2 trays, you can specify which tray to print from first. So many different options on your larger printers. When you go to configure that printer sharing, there's basically three permissions that you can configure. Print, in other words, who's allowed to send documents to the printer. Manage this printer, what users can modify the printer settings and configurations. And manage documents. That provides a user the ability to cancel, pause, resume, or restart a print job. So let's take a little bit of a live view at print management. Here is a server that has printers installed, and as you can see in the view here, devices and printers, these printers are published and they're shared. So they're published through a group policy that allows them to be available to users. If I look at this from the perspective of the user, not the server administrator, I can see all those printers being published. Now, some of these are local printers, but if you look at this here, on server 1 FTL, on server 2 WPB, well, that is this right here publishing those printers. They're not printers that are installed on this user's computer, but they're made available to the user through group policy. The user did not have to do a single thing to have all these printers available to them. So they can simply pick which printer is preferred that they print to. And as you can see here, they're printing to a Dell laser printer. That's the power of print management and publishing printers in group policies. Let's jump back over here. Now, the other thing that you can do is you can make drivers available to more than just your specified users. So, for example, these are all WinX64, but down here, see this one other one, NTX86? You can publish, for example, 32-bit drivers in addition to your 64-bit drivers. So if you've got a 32-bit client that needs to have printer connectivity, the printer driver is available to automatically be installed for them. Otherwise, the user would have to come up with a driver disk. This way, it's all done seamlessly for the users. So I hope that that gives you a little bit better insight into how DFS and branch cache and print management works. Understand that DFS, it's a set of technologies that enables your Windows Server to organize those shares and replicate them so that you have uniform availability throughout your network. The branch cache is a way to be able to provide those same files to a branch location over a slower link and have it available without them having to consume the bandwidth between the headquarters or main office. And of course, then the print management allows you to populate network printers for the end user without having to directly connect printers on their each one of their computers. So that is our lesson 11. Thank you very much.